Namaste. To all our viewers watching this video, it's Ishita from STES Rocket, team number 22. Present you with the project design report for LASC 2022 1 km height target solid rocket category named Midnight Sun. Our launch vehicle is 2.3 meter tall fiberglass composite body and is powered by L-class STES motor, which will allow us in hitting target apogee. For mass estimation, this year we use the following weight estimates for the rocket. The weight has been maximized to the guarantee that we reach our desired apogee without difficulty. For altitude prediction, we did a simulation test on open rocket software and our rocket hit the desired apogee of 1069 meters. Since the target apogee is 1000 meters, we have allowed for the margin of error of up to 50 to 100 meters here to allow for an extra weight that may introduce during the rocket's production. For stimulated CG and CP, the graph on the screen displays the stimulated CG and CP location during the flight as well as the on-flight stability of 3.37 calibers.
Moving on to aerostructures. The upper airframe will hold the rocket's recovery hardware as well as the avionics and payload stack, while the booster tube will include the motor, fin assembly, and boat tail. Boat tail is used to reduce base drag and is 3D printed from PETG material. 4 trapezoidal fins laser cut out of aluminum 6061 are used. Flutter calculations were done to determine dimensions. Fins are held and assembled using PETG fin can rings and aluminum slots.
The airframe is divided into 3 components: the nose cone, the upper airframe, and the booster tube. The 3-stone LD-HEC nose cone is made from 4 layers of 400 JSF fiberglass and has 6061 aluminum nose tip for precision top and heat resistance. It also houses both the parachute for recovery. Launch vehicle contains 2 aluminum 6061 bulkheads used for recovery and thrust plate, and a 6 3D-printed retainer mounting for avionics and payload. Coupler tube of material aluminum 6063 is used to connect the upper airframe with the booster tube.
Propulsion team have researched and developed the L-class solid rocket motor for Midnight Sun. Our motor consists of 6 weight variant using potassium nitrate sorbitol and FP2. You can see the composition on the screen. We perform multiple mini tests to finalize this composition. We have used open motor software for developing the motor. You can see the simulation and results like ISP and impulses as well on the screen. While developing the nozzle, we took references from the other teams and got converging and diverging angle, which worked for us. And after getting CAD files ready for the propulsion system, we headed to the manufacturing part. Using aluminum alloys for machining, a wing tool and lathe machines were used.
So, talking about avionics subsystem, currently we are using 2 COTS flight computer and 1 asteroid computer for recovery events and data logging. For redundancy, 2 sets of black powder charges for each recovery event are handled by 2 COTS altimeters. Primary events are taken care by Proton, while the backup by Quantum with a delay of 2 seconds. The drogue comes out at apogee from the nose over and main at 1000 feet. All the electronics are powered and armed separately to allow additional redundancy. To send flight data in real time, our asteroid avionics unit send pertinent flight data like altitude, GPS, recovery ejection sensors, battery voltage and velocity to ground station over 900 MHz by Zigbee S3P Pro.
In ground station, we are using a Yagiyoda antenna linked to an XB, which is linked to another XB inside the body of the rocket. The transmission happens from XB inside upper airframe, which transmits flight data to the ground station XB at 900 MHz. The raw data received is then processed through Node-RED and then stored in Influx database, which is then converted into presentable data and graphs through Grafana to monitor it in real life.
We are currently developing a dead reckoning solution using 6 degrees of freedom inertial measurement unit, which includes a 3-axis accelerometer and 3-axis gyroscope sensor. We are going to fuse these 2 sensors using Kalman Filter to accurately estimate the state of the rocket, that is position and orientation. Also, we are going to use quaternions for orientation estimation because they are memory efficient and are easy to normalize than angular angles.
Talking about the recovery system in Midnight Sun, it includes a single separation dual deploy mechanism, which means the drogue chute acts as a pilot for the main chute. The drogue is 24 inches elliptical parachute with CD of 1.6 and the main is a 72 inches toroidal parachute with CD of 2.2. At apogee, black powder charges ejects the drogue, which brings down the descent velocity to 24 meters per second. And at 1000 feet, tender descender separates from the drogue line and pulls out the main chute, bringing down the descent velocity to 6 meters per second.
While the COVID lockdown was a huge bottleneck of our team's progress, it didn't stop us from participating in more challenging events. This year is special as it will be our first flight event after being in ATIS for 3 years and team's first with an all-asteroid motor. We are looking forward to see what other teams bring to the table on August this year. Stay safe, take care of yourself and your loved ones. Obrigado.